Greetings. Here we have one of the simple questions from Signals and Systems asked in GATE ECE 2014 set 3 for 1 mark. Now given like this, for an all-pass system, this is first order all-pass system where magnitude of frequency response equal to 1. Yeah, for the first order all pass system, magnitude of frequency response will obviously equal to 1. So for all omega, see in this case for all omega means, yeah, on distal case what we do is for all omega we can write like this: omega belongs to negative pi to positive pi, right? Now if real part of A not equal to 0 and imaginary part of A also not equal to 0, then B equals. Now both real and imaginary components are present for this A. This A is pole, right? This is pole A. That means this pole A is a complex pole. Yeah, because both components are involved. So therefore we have a complex pole A. Now in this scenario he is asking then B equals. That means to maintain this definition or to maintain this condition, what must be this B? Yeah, the answer is what? In no time we could go for option B, A conjugation. See, in overlook what we do is some of the students will definitely go for option C, 1 over A conjugation. Why? In order to satisfy this definition, each pole of each pole of this h of z should become in pair with a conjugate reciprocal 0. So as of now here we have one pole, so this pole should come in pair with conjugate reciprocal 0. Then in overlook we take B is equal to 1 over A conjugation, but we have to go for B is equal to A conjugation. Yeah, now please do watch this lecture until end so that we will try to investigate how come we meet this definition or condition, so that B is equal to A conjugation is the right choice to meet this condition. Okay, so now we'll go for it. Let's go for this all pass. Then we have, let's say that you have an all pass system. Let me take like this: AB indicates all pass. Let all pass system be h of z like this. Okay, now frequency response magnitude or magnitude of frequency response is constant for all frequencies. That's the meaning of all pass system, right? So this fellow will not show any partiality among various frequency components. He will give equal priority for all frequency components. That's the meaning of all pass system. That means all frequencies will be allowed. So we could write like this: frequency response, or we will write like this: magnitude of frequency response. Magnitude of frequency response is constant, and this is constant for all frequencies. Okay, so it's constant for all frequencies. So that is, we could say like this: h of frequency response, h of e power j omega. So magnitude of frequency response is equal to, say, A. In general, this could be any real constant, not necessarily be 1 always. Yeah, so the magnitude of frequency response of this all pass system could be any real constant, need not be 1 always. Very important point is this, because most of us think that magnitude of frequency response of all pass system is always equal to 1. So but it is need not be 1 always, could be any real constant. This is a real constant. So this is a real constant. Now this indicates that the gain of all pass system, is a real constant. Now in order to satisfy this definition, okay, now this is our definition. So we will put our definition as follows. So we will put our definition as frequency response of this frequency response So magnitude of the frequency response of all pass system is A. So let's put our definition as follows. A could be 1, 2, 3, anything. Okay. Not necessarily be 1. That we are well aware of. Now, in order to satisfy this definition, each pole of this h of z, each pole of h of z should be paired with a conjugate reciprocal 0. So you can write like this. In order to satisfy this definition, each pole of h of z, okay, all pass filter or all pass system function or all pass system, each pole of h of z should be paired with a conjugate reciprocal 0, with a conjugate reciprocal 0. So if we follow this, definitely we can satisfy this definition. All right. So each pole should be paired with a conjugate reciprocal 0. All right. So therefore, a rational all pass system, we will take, let us take a rational all pass system. We need, of course, a rational all pass system so that we can resolve it easily using partial fractions if possible. So let me take, a rational all pass system has the general form. So a rational all pass system has the general form like this. So let me take my system, all pass system. Okay, so let me take any real constant here, need not be 1 always. So I'll take product of the pairs as follows: z power minus 1, say minus ak conjugation divided by 1 minus a sub k multiplied by z power minus 1. Okay, so this ak should be less than 1. Now this k, whatever this sub k we have, could be anything. So I have p number of zeros. So I have zeros in the factor form now. I have p number of zeros and I have p number of poles as well with real constant a. Okay. Now we can construct things like this. If there is a pole, if there is a pole Ez, or if there is a pole at z is equal to a sub k, let me take my pole like this, then there would be a 0. Then a 0 will be at z equal to 1 over ak conjugation. Yeah, so that is what this, that is means, so if a pole is at z equal to ak, then there would be a 0 at z equal to 1 over ak conjugation is what this statement is about. Okay, now that is, so what we could decide is as follows. Now we could think of this way. Okay, so a pole at ak, if I take a pole ak, that is r e power z, because real part of a and imaginary part of a not equal to 0 means we have a complex pole. So in general case we will take a complex pole like this. Now this complex pole is paired. This complex pole is paired with a 0 at, we could say, 1 over ak conjugation, that equal to what? this is nothing but 1 over, here we have ak equal to r e power j theta, so we get e power minus j theta. After performing conjugation, e power j theta becomes e power minus j theta. Now the beauty is, so magnitude stuff is 1 over r conjugation. This would be anyways real. Now you take this quantity to numerator, this becomes e power positive j theta. Okay, so 1 over ak conjugation is equal to 1 over r conjugation e power j theta. Now if your impulse response, because h of z or h of z, let me take our here you see. Now this is your system, right? All pass system. I can take its impulse response in time domain, that is, so if this h of n is real, then ak is equal to ak conjugation. That is a well-known fact. So a well-known fact is this. Now anyways, we have, let's go to our basic definition, that is this one, you see. So we took let me go for this. Okay, yeah, so our general form is like this. Now out of this general form, we will construct a first order all pass system. Why we will construct a first order all pass system? Because in the given question you have first order all pass system. Yeah, now whose frequency response magnitude must be equal to 1 when b is equal to this a conjugation. This b must be a conjugation, then only we can satisfy this definition. That we are going to prove now, right? So for that, in that journey, we took a general form. Now from this general form, we will take a single order all pass system. Now we will try to plug in b is equal to a conjugate in that single order all pass system. Then we will appreciate the fact this will be satisfied. Alright, so therefore what is let me take down my single order all pass system. Okay, so single order all pass system. Okay, see, now here we have cascade of this combination, right, like this. So out of this cascade I will just take one. Okay, because here we have p zeros and p poles, I'll just take only a single zero, single pole pair as our system function. So HAP of Z is now Z inverse or Z power minus 1 minus, let me take k is equal to 1, then we have A1 conjugation by 1 minus A1 multiplied by Z power minus 1. This is my first order all pass system. Okay, so what did we do? So this we took k is equal to 1, so we made this z power minus 1 minus a1 conjugation. You see here from this let me arrange things properly here. Okay, you see, in this k is equal to 1, so z power minus 1 minus a1 conjugation, z power minus 1 minus a1 conjugation, then 1 minus a1 z power minus 1, so 1 minus a1 z power minus 1. Now this is my system, so let me take my frequency response. As z is a complex variable, so I will take my frequency response as you take z equal to e power j omega, then this becomes frequency response, right? So e power minus j omega minus a1 conjugation divided by 1 minus a1 e power minus j omega. Just plug in z equal to e power j omega in both left and right hand side as well. Okay, so now from this numerator you take e power minus j omega as common. So now you will get 1 minus a1 conjugation e power positive j omega. Okay, so multiplication of these two is equal to 1. So now divided by 1 minus a1 e power minus j omega. You don't take anything common from the denominator, you leave this as it is. Okay, now what do? So in the left hand side you have your h of e power j omega. See, h of e power j omega. Now if you observe things carefully, see in the given question, so in the given question here, h of e power minus j omega is equal to 1. I can take h of e power positive j omega also. h of e power positive j omega or h of e power negative j omega, no problem. The moment I take magnitude, we definitely get 1. Yeah. So therefore, if I take magnitude on both sides, then what do we get? Then we get like this. Let me take magnitude. Okay, so h of e power j omega in the left hand side. Now what is magnitude of e power j omega or e power minus j omega? That means e power plus or minus j omega magnitude is always equal to 1. Yes or not? So just use it here in the right hand side. So I'm taking its magnitude, that becomes 1. If it is 1, so we have remaining is what? This one. So that is 1 minus a1 conjugation e power j omega magnitude divided by, so what do you have here? 1 minus a1 e power minus j omega. Here we have positive j omega, here we have negative j omega. So take their magnitude. Now what is the value for this? Now think of, say 1 minus a1 e power minus j omega is equal to x. Okay, here we have x magnitude. Now this becomes what? If this quantity is x, there is no second thought, this quantity becomes x conjugation. Okay, so it's needless to say x magnitude must be equal to x conjugation magnitude. In that scenario, this is equal to 1. See, we have satisfied the definition. Yes or not? So we have satisfied the definition. How did we satisfy the definition? By just taking, see, if we have here a1, this must be a1 conjugation. Okay, that means if it is a1, this must be a1 conjugation. If I have here c1, this must be c1 conjugation. So in that scenario only we can satisfy this condition, yeah, or this definition. So therefore the correct option for this is what? B is equal to A conjugation. Okay, see, now the beauty is this. Let me take my complex jet plane. So this is my real jet and this is my imaginary jet, and this is my complex plane. As jet is a complex variable, this is a complex plane. So let me put down things this way. For now, let's draw a unit circle. Okay, so we have a circle, unit circle we have like this. Now you see, let me take a pole here. So a pole along this is real, a pole along this is imaginary. Now a pole in between must be a complex. Now this is a complex pole because we assumed we have a complex pole, right? See, we assumed we have a complex pole. AK is equal to R e power j theta. Now this is what? We have a positive phase. Theta is positive there. So therefore, I'll go like this. I'll go like this. Now from here to here, now from this real axis, I take anti-clockwise journey by theta. Yeah, then I reach this pole. So I have a pole like this. Okay. Now I have here, this is my pole, say A1. Okay, my pole is here a1. This is my pole a1, where a1 is complex. So this is my real and this is my imaginary. So real part of a not equal to 0, imaginary part of a also not equal to 0. So we have life, complex life for this pole. Now 1 by a1 conjugate, 1 by a1 conjugate is again we obtain, see, of course here we have 1 by r, but here see the phase whatever we have here, the phase in this case and phase here both are same. Yes or not? The phase for 0 and the phase for pole both are same. See, both are positive. That means 0 must also lie along the same line. Alright, so I'll just do 1 by r1. So 1 by r1, maybe somewhere here we will take a point. What is there? I'll take a point something like this. So this is my 0. This is my pole. Now see, both 0 and phase lying on the same line. So this is the radial line lying on the same radial line like this. Okay. Now this is one of the causes satisfying this condition or satisfying this definition. Magnitude of this frequency response equal to 1. So end of the day, we could happily agree that simply z power minus 1 minus p divided by 1 minus a z power minus 1. So to satisfy this definition, this b must be whatever I have, that conjugation. Okay, so that's it for today. So please do watch this lecture series until the end, and please do subscribe. We have many interesting concepts now queuing up. So for today, so for now, we want to say thank you.